Alright, now guys, when we look at today's lesson, we're just going to be looking at isosceles and equilateral triangles. And guys, we're going to make this really easy today. Super, super easy. There's basically two things you need to know for today's lesson. In the isosceles triangle, the sides are... How do we complete that statement? In an isosceles triangle, the sides are...
Two congruent sides.
We have a pair of congruent sides. And opposite of those sides, the base angles are also congruent. So our two base angles are equal. And that's everything you need to know about isosceles triangles. For real. Okay. And then this little guy up here at the top, this is called the vertex angle. And then the side at the bottom, that's called the base. Which is what we call these base angles. So you're going to have two congruent sides, and then the angles opposite of those congruent sides are also congruent. So what's an equilateral triangle? This is what an isosceles triangle is. What's an equilateral triangle?
All sides are the same. Three congruent sides.
Very good. I'm glad that at least Danielle will believe to be called upon. Go ahead, Danielle. Say it again.
Oh, okay.
All the sides are equal, so all the sides are 60.
Okay. So all the sides are equal, so all the angles are 60 degrees. Okay, good. So that's what we need to know about equilateral. All the sides are the same, and all the angles are 60 degrees. Right? Now, is there any limitation on the value of the sides? So there's no limitation on how long the sides can be. But the angles can only add up to 180. But for equilateral, the individual angles are 60. And then for isosceles, we have two angles that are also the same. Alright, so those are the big ideas for today. So let's take a look at this in a couple of examples. So look at example 1. I guess I should probably mark which sides are the congruent sides in our isosceles triangle. So what do I know looking at figure 1?
3x minus 4 equals 2x.
Alright, so 3x minus 4 is equal to 2x plus 9. Now Danielle, I'm going to pick on you a little more here. Why is that true? Yep, because we have two sides that are the same, therefore the base angles are the same. Alright, so let's go ahead and solve for x. What do we do next? What do we do, guys? You guys tell me what to do. Alright, so we're going to subtract 2x from both sides. So that leaves me now with x minus 4 is equal to 9. Now what? Add 4. Therefore, x is 13. Yay, we're done with that problem. Okay. Number 2 is interesting. Okay, the whole triangle is not an isosceles. But we do have two isosceles triangles here. What are your thoughts on this? Cameron?
Well, the isosceles triangle, the smaller one, both are equal, they're both equal to 80, not together.
Okay, so individually, this triangle right here, and that triangle, okay, so the three angles add 180. Okay?
So 54, since they're equal, and find the measure of that triangle, subtract the base.
Oh, okay. So since my two base angles are the same, so let's go ahead and write that out. So what you're telling me, Kevin, is since these two base angles are the same,
Yes.
if I subtract out my vertex angle,
Yeah.
so 180 minus 54, and take that and divide it by 2, that'll give me the value of that angle?
Yes.
Okay? Well, let's do that. So what's 180 minus 54? No,
No, it's 120.
126,
And then it's
and then 163. Alright, so that tells us then that our angles here are 63 degrees. Alright, that's very good, but how does that really help us get to x?
Well, I just saw that.
Okay, alright, it's not
I
bad.
can
We'll piece our way there if we have to, right? It's like doing a puzzle. We've got this piece in. Cheyenne?
So why do you subtract it by 54?
Because remember the sum of the angles for any triangle is 180.
Is the 54 like an angle? Like is it the top angle?
54 would be the vertex angle of that isosceles triangle. So yeah, if I have the vertex angle and I want my base angle, you're always going to do this. You're going to subtract the vertex and then divide it by 2. And that'll give you your angle for the base angle. Okay, so Keanu, think you know where to go from here?
Yeah, since the 54 is right next to the right next to it, wouldn't that be a right angle?
No. No, we are not going to assume. Unless it has the box, we cannot assume that's a right angle.
Well, since we know the value of the bottom ones, can we use the supplementary at the bottom angle? Because it has the angle to make a supplementary. So therefore, you find that measurement. You can,
Or would you find the whole triangle? Because you had one of the corners.
Oh.
And next to
So I've got 63 in this corner, right?
Yeah.
Whoops. And I've got 63, or the x on here. But what I don't have is that whole angle.
Yeah.
Other ideas? So a lot of different ways we can solve this. I know of at least 3 already. What? Okay. All right, let's do this one piece at a time. So you're telling me in order to find this vertex angle, we're going to take 180 minus the 63, right? Okay. 180 minus 63 is 117. So that tells me now that this is 117 degrees. Good. Not bad. Not bad at all.
Even that is an isosceles triangle.
It is isosceles. So what's that other corner then? So okay, so we know that's going to be x. All right, that's good. Okay. Yes. Or 63 halves. Okay. Now, so this is actually really good. You guys did this perfectly. I'm going to show you a couple of shortcuts that can be done differently, make it a little bit smoother. Believe it or not, I'm with Shelby on this one. First time I ever solved this problem, I did the same thing, where I found that corner first, doing Keanu's method, and then subtracted it from 180 to get the 117, and then here's what I'm going to do. Now that I subtracted 63 from 180 to get 117, now I'm just going to undo that one more time, because we're going to repeat what we just did here. So we're going to take, get a different color, let's go green. So we're going to take 180 minus 117 and divide that by 2. Well, what's 180 minus 117?
63.
Oh, that's not odd. 63. Hold on, didn't we already start with 63 somewhere? And then what do you do with that 63? Divide it by 2, we get 31.5 degrees. Now this is why this is kind of interesting. Notice that these two steps right here just undo one another. Kind of like, well, duh. Why go? It's like taking 2 steps forward, and then knowingly and purposely take 2 steps back to go right back where you came from. Well, there's a reason behind this. If we were to tie some concepts from the earlier lessons, if I look at this outer triangle, what type of an angle did I create with the 63? an exterior angle. You guys see how 63 is the exterior angle of that right triangle? Not the right angle triangle, but the right side triangle. Okay? And what did we talk about with exterior angles?
Isn't it if they're equal to the opposite? Or I'm not sure.
Yeah.
But they're equal.
It's equal to the opposite interior angle. So that means that 63 is equal to x plus x. And therefore 63 is equal to 2x. So guess what x is? X is 63 divided by 2. A lot of different ways to solve this problem. In fact, so we've already done one right here. We just did a second way, and now I'm going to do a third way. And I can't remember who proposed this. I think it might have been Danielle, but I'm not positive. Well, if we know this angle, and I know x is over here, and I know this is x, and I could probably figure out that whole angle. Let's see if we took that approach, where that would take us. So we've got 63 plus the corner x, and then that big upper corner would have been 54 plus x. Let's all that equal to 180. And see if we get the same answer. And we should. Watch this not come out correctly. 63 plus 54, 117 plus 2x is 180. And wow, look at that. X is again 63 halves. So when you're doing problems like this, you're probably not all going to be on the same page. You just want to keep trying at it, right? I like how Karen is like, well, I don't really know how to get to x yet, but at least I know that that angle is 63, and that's a step closer. These are types of problems where you don't want to give up. Keep plugging away, trying to get the different values. So that'll really help with that.
Yay.
Oh, we're not done yet. All right, I want you guys to do 3 and 4. 3 and 4. I want to hear some ideas. How do we do number 3? Danielle? Guys, quiet down, please. I want to hear this.
Alright, so you take 180 and subtract 110, and you get 7.
Okay.
And then 70 divided by 2 is 39.
All right, now I'm going to stop you there. Because now your comment is, what does that actually give us? I mean, why are you doing this, Daniel? What are you trying to get out of
I'm
this
trying
activity?
to get the 180, like, because it's not isosceles triangle, so both angles are the same. So that equal that is
Alright, so
35.
that's how we found the 35, okay? So then what did you do?
35 equals 2x plus 3.
All right.
And you subtract 3 for both sides, and then take 32 equals 2x. And so 2 and 16.
Very good. Perfect approach. Did anybody try something different? Okay. Morgan, what'd you try? No, not logo. So,
I did 2x plus 3 plus 2x plus 3 plus 110, and then added like factors, and then subtracted 116 and divided by 4 and that.
all right, slow down there. So I got 4x plus 116 is equal to 180. All right, keep going.
Then subtracted 116, you get 4x equals 64, then divided by 4 and got x equals 16.
All right, 2 different approaches. Both approaches should work. Okay, so whatever one you're more comfortable with. You want to do the fact that all 3 angles have the 180, we should be good. Now, a lot of you guys were just telling me that 2x plus 3 plus 110 equals 180. Okay, guys, triangles have how many angles? 3. So all 3 angles have to add up to 180. So if you're only adding 2 angles, you're not going to get to 180. You need to have all 3 angles. All right, who has number 4?
I'm bad at it.
I have
to spread the wealth a little bit here.
What?
Sam, go ahead.
Alright. So you take 180 minus 120, you get 60. You take 60 divided by 2, you get 30. And 30 plus 10 is 40 divided by 5.
Wonderful. Now, where did all that come from? What does 30 equal?
I did that. Okay, 30 is equal to 5x minus 10.
Okay.
You add the 10 divided by 5. You have your
And we could probably also do the same approach we did over here. 5x minus 10, 5x minus 10 plus 120. And we should get 10x is equal to 80. And then x is 8. Alright, so that pretty much ends our notes for today. Yay, it's over! Woo!